go ahead and get rolling here. Again, this is Chapter 10, Trigonometry. Okay, so this topic is really something that you would have had last year in geometry. Would you go as far as we're going to go in this class? No. But you would have been introduced to trigonometry. Anything we do in the first couple days should be all review. So all this stuff, first few days, should be completely review. But like a lot of things, it takes a couple times to really get it down, and so hopefully you will this time. Hopefully you'll get it down and it'll make sense to you. You need to ask questions, ask questions, ask questions, ask questions. You're not sure what's going on, ask. Ask while I'm teaching it. Okay? Because I'm trying to do the things to get you to understand, and so if you'll ask while I'm teaching it, that's the best probability of me being able to say them what will help you and get you to understand. All right, first off, this is right triangle trigonometry. It involves right triangles. Next chapter, we'll learn how to do what are called oblique triangles, non-right triangles. But most of trigonometry involves a right triangle. And you can't try to do it if it's not a right triangle. Also, trigonometry is based upon the concept of similar triangles. You guys had that last year in geometry. And you should have learned in geometry, I know you did, I know you had it, that for similar triangles, the angles are congruent and the sides are proportional. So you might have a smaller triangle and then maybe one twice its size. Those would be similar triangles. And the ratio of the sides stays in a proportion. That's the basis of trigonometry, and that's why the trig functions work. I'll mention a little bit more about that when we go on in just a bit. So let's get started here. And it's the three basic trig functions are for the acute angles of a right triangle. So the three basic trig functions are only for the acute angles, all right? Acute angle, angle less than 90 degrees, right? Which would be angle A and angle B in both of these examples, not angle C. Angle C is 90 degrees. You can't use the trig functions on the 90-degree angle. It's not for them. It's for the acute angles of the triangle. All right, so you got to know your basic, let's see if I can get that to go away. You've got to know your basic trig functions if you're going to get anywhere and you're going to know anything of what's going on. So let's start off with the first one. And the first one is the sine, S-I-N-E. So I don't know, a month and a half ago, the trig functions came up. So you can raise your hand and tell me what the sine is. What side over what? The sine. What over what? Noah? It is the opposite side, so you got that one right. But it's not over the adjacent, so the only thing left is the hypotenuse. And I'm only going to write it out once, and after this I'm going to abbreviate. So it's the opposite side over the hypotenuse. Nothing today, thank you. So the sine opposite over the hypotenuse. You can see down below the abbreviation. Okay, so it's not sin. You don't say sin. I've heard students say sin. I'm hitting the sin button. I think they like that. Look at me, I'm hitting the sin button. Okay. It's not a sin button, it's the sine button. S-I-N for short, you save one letter. All right? If you say sine, you don't say sin. All right, and so the sine for angle A, and again, what is the sine? It's going to be the opposite over the hypotenuse. And in this situation, you know what? Let me go ahead and just put the letters in. And we can leave that there. What is the opposite? So here's the key to everything. Look at the top triangle. Here's angle A right here, correct? And I do that in your notes. So for angle A, if you go opposite it, the A right here is the opposite side. Little a, side little a. So the opposite is A. Now the hypotenuse is always across from the right angle. And hopefully you remember that. The hypotenuse is always along the side. The hypotenuse is always across from the right angle. So the sine of angle A is A over C, opposite over hypotenuse. However, if you were going to do the same triangle of angle B, now I put the triangle twice because I don't want to put a whole bunch of stuff on the first triangle and then it's going to be so much stuff where you can't see. But when you do the sine of angle B, okay, thanks, E-sword. I don't know why you're coming up, but you're coming up. Must have hit something. So when you do the sine of angle B, the opposite is side B for angle B. So now the top is going to be B. What's the opposite of angle B? What side? Side B. Again, the hypotenuse is always across from the right angle. So the sine of angle B is B over C. And you've got to keep track of what angle you're dealing with. Notice I did the two acute angles, angle A acute angle, angle B acute angle. The trig functions are only for the acute angles. So it's different depending upon the angle you're dealing with. Why? Sine's always opposite over hypotenuse, but the opposite side is different depending upon the angle. It's different depending upon the angle. All right, so second one is the cosine. CO and then SINE, the cosine. So does anybody remember the cosine? Say it if you know it. It's the adjacent over the hypotenuse. Cosine is the adjacent over the hypotenuse. All right, so go back to the first triangle, because the first example here is cosine A, right? We're right here dealing with cosine A. And you got to go back to angle A, and we got to figure out which is the adjacent side for angle A. Okay, well, here's a newsflash. Look at the top triangle. This side's the opposite of angle A. Agreed? This side is the hypotenuse. Agreed? What's left? The only one left is the adjacent. This is the adjacent side. It's the only one left. The adjacent side is one of the sides of the triangle, or one of the sides of the angle that's not the hypotenuse. But again, if you know what the opposite is, and you know what the hypotenuse is, the other side left has to be the adjacent. So for angle A, the adjacent side is side B. So the cosine of angle A is B. And of course, the hypotenuse is C. Ding, 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 ding. Woo, 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 woo. Ding, 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 ding. Woo, 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 woo. Yeah, that's the big thing. That's a big picture concept. Go ahead and get your calculators out. Huh? It's going to go the other way around. Go ahead and punch in your calculator. Let's do something easy. Let's put in, all right, in some of your calculators, you have to hit the SIN button first, the sine button, and then put in the number of degrees. Other calculators, you put the degrees in first, and then hit the sine button. Most of yours, you're going to put the sine button first. All right, so let's do 60 degrees and hit your sine button. Okay, do you have 0.8660, etc.? If not, you did something wrong. Again, 60 degrees and your sine button, or your sine button and 60 degrees. Does anybody not have now 0.8660? What do you have? What does your screen say? Are you in radians instead of degrees? Probably. Okay, you have to have your calculator in degrees, so you're going to have to figure out how to get its mode into degrees, not in radians. You're probably in radians. That's not good. Okay, if I had a 60-degree angle, by the way, what does angle A and angle B, those two angles together, how many degrees do they add up to? 90. They have to, right? Because this angle's 90. So if A is 60, what's B? 30. Let's do the cosine of 30 degrees. Punch in 30, hit cosine, or punch in cosine and hit 30. Do you have the same number? Yeah, because the ratio is the same. You know what the 0.8660 is? For angle A, it's the adjacent over the hypotenuse divided out. For angle B, it's the opposite over the hypotenuse divided out. All right, newsflash. The sine of 10 degrees equals the cosine of how many degrees? Sine of 10 degrees equals the cosine of 10 degrees equals cosine of, if this one's 30, how much is this one? 80. Okay, you did my 10, I was doing a different one. Yeah, of 80. The cosine of 40 degrees equals the sine of 50 degrees. The sine of 1 degree equals the cosine of 89 degrees. You getting it? The sine of 20 degrees equals the cosine of 70 degrees. You can punch it into your calculator. You'll get the same numbers. Punch in sine 10, punch in cosine 80, same number. Punch in sine 25, cosine 65, same number. Okay? That's the relationship between the sine and the cosine. All right, finishing out the cosine for angle B. So again, notice for angle B here, here's the opposite. It's not that side. Here's the adjacent. It's not that side. So, I mean the hypotenuse, it's not that side. So the adjacent has to be A. So for cosine angle B, the adjacent side is the A, and the hypotenuse is the C. And yes, Dawson, those two work because they are complementary angles. The sine of 10 equals the cosine of 80. The cosine of 30 equals the sine of 60. The sine of 5 equals the cosine of 85. That relationship. All right, you'll see that more and more as we go on. The third one, so cosine. So we had sine, cosine. The third one is the tangent. All right, ladies, you can sit there and hold your calculator up to your face and punch the tan button forever, but you won't get any darker. I wish it would work because I stupid have these white walls from the summer that I can't get rid of until the summer, and I would just sit there and hit my tan button, but it won't tan you one bit, all right? It is a tangent button. And the tangent is the opposite side over the adjacent side. Tangent is the opposite over the adjacent. Stop laughing about my white walls. They're horrible. I need some of that stuff that tans you with, and then it'll probably turn like orange. All right. So again, I know we got a lot of stuff up here, but go back to angle A. What's the opposite side of angle A? Side A. What's the adjacent side of angle A? Side B. So it would be A over B. And again, you got to take track of what angle you're dealing with. Now when I'm doing angle B, notice the angle always comes right after the trig function. What's the opposite for angle B? Side B. What's the adjacent for angle B? Side A. And you can see these are inverses. If the tangent A equal 2, the tangent of B would be 1/2. If the tangent of B is 3/4, the tangent of A would be 4/3. They're reciprocals, inverses. Okay? That's the relationship, and that's the way they go. All right, so all that said, then, you got to memorize these. You got to memorize, you got to memorize, you got to memorize. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. You have to have those memorized. You have to. So sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. You gotta memorize them. They've gotta be every time. You gotta know those. You gotta. And I'm not a big acrostic person or, thing to remember to give you a clue, because then you have to remember the thing. But, you may have heard a teacher say SOHCAHTOA. Oh, great, SOHCAHTOA. What in the world is that? Some fictional Indian, right? SOHCAHTOA. So, all right, soak, S-O-H, C-A-H, TOA, T-O-A. You see it? So, Toa. I think so too. All right, that's my opinion. But some people like acrostics. You like words. That's how you learn. So, SOHCAHTOA away. All right. Whatever floats your boat, whatever's going to get you to remember, I'm for. But you got to get them. 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 All right. So notice we just did 3 fractions, right? Opposite over hypotenuse, fraction. Adjacent over hypotenuse, fraction. Opposite over adjacent, fraction. Another word for fraction is a ratio, right? So finding the ratios of the acute angles. Finding the ratios. You'll have to do some of this tonight. So first off, something we already know to do. At times you'll have to use the Pythagorean theorem. Pythagorean, the Pythagorean theorem, to find the third side of the triangle. All right, we already know how to do that. And by the way, if you know your right triangles, you should already know what the answer to the hypotenuse is. But again, lest you don't remember, let's do the Pythagorean theorem. Let's take the square of the sum of the sides squared, right? 8 squared is 64. 6 squared is 36. That's going to be the square root of 100, and we all know the square root of 100 is 10, and you should have known it from the beginning, because what kind of triangle is this? 3, 4, 5 triangle, right? It's a double-sized 3, 4, 5 triangle. 3, double the 3 to 6, double the 4 to 8, double the 5 to 10. 3, 4, 5 triangle. Carpenters use it all the time. It's a main triangle. Okay, now that we know the 3 sides, we can go about and answer the question of finding the sine of z, the cosine of z, and the tangent of z. All right, let's do them in order. Sine z means the sine of angle z. And again, I'm just trying to help you guys remember, so I'm going to put the middle step. What is the sine? The opposite over the hypotenuse, right? So look, here's the key to it all. Make sure you're dealing with angle z, right? You've got to deal with angle z. Which side is the opposite of angle z? It's the 6. So the opposite is 6, and the hypotenuse is 10. Make sense? And are we going to leave a fraction unreduced? That doesn't make sense. We never do that. So what is the ratio for sine z? 3/5. If your calculator was going to give you the ratio, you know what it would say? It would say 0.6, right? 6/10. Because your calculator gives you the ratio in decimal form. We're going to leave the fraction exact answer. Okay, so now we'll just go through and do the cosine of z. And everybody now knows that the cosine is the adjacent over the hypotenuse. Again, we're dealing with angle z, right? So look at z. What side is the adjacent? Say it if you know it. 8, right? Has to be, because the opposite is the 6, and the hypotenuse is always across from the right angle. And the hypotenuse is always the hypotenuse. It's 10. And we end up with 8/10, and we're going to reduce that down to 4/5. and we've got the ratio for the cosine. And we'll do the last one. I'm going to come up here. You can go below wherever you want to. I don't care. Tangent of z. And we all know SOHCAHTOA, or we actually know the opposite over the adjacent. And again, what's the opposite of angle z? It is the 6. What is the adjacent of angle z? It is the 8. And we'll reduce that thing down to 3/4. Right. Should have been black. My pen changed on me. But again, notice we did angle z. We didn't fool with angle y. All right, email, go away. We messed with angle z. We didn't mess with angle y. Right, now we'll deal with angle y. So I have the same exact triangle copied again just to keep our notes clear. Normally you just have one triangle. You're doing it all in one, but I just recopied it so we'll keep things straight. So what's the hypotenuse of the second triangle going to be? 10, because it's the exact same triangle, okay? Only this time you're dealing with angle y. So again, notice now what's the opposite? Right? The 8 is now the opposite. Therefore, the 6 must be the adjacent. But hey, you want to go a little quicker? The sine y is exactly the same as what? Cosine of angle z. What was the cosine of z? 4/5. Right? What was the cosine of z? Now again, you can do opposite over hypotenuse. What's the opposite of angle y? 8. What's the hypotenuse? 10. What is 8/10 reduced to? 4/5. What's the cosine of y? That's the same as the sine of z. So if I want to save some time, I'm going to say 3/5. And again, you can do adjacent over hypotenuse. You're still going to get 3/6. And do the tangent of angle y. What do tangents do between the acute angles? They flip. So what's the reciprocal of 3/4? 4/3. Now again, you can just go ahead and do adjacent, opposite over adjacent for angle y, but you'll get 4/3. Okay. Again, I drew the triangle twice, but understand it's the same triangle. You usually only have one. I'm separating them right now to make clear which angle you're dealing with. And to help you to understand clearly, I hope, that the opposite and the adjacent sides depend upon the angle you're considering. That's really important. Not hard, but you just got to keep track of that. It's in respect to the angle you're considering. All right, so let's do this problem here. All right, do we have all three sides right now? No. So the first thing we got to do is we got to find that third side. Are we finding the hypotenuse or one of the legs? Which one? Say it. One of the legs. So what's the formula? Square root. What goes first? The hypotenuse. Yep, always goes first. And when you're solving for a leg, is there a plus sign or a minus sign? It's a minus sign. Don't mess that up. Finding the hypotenuse, it's a plus sign. Finding any leg, it's the square root of the hypotenuse minus the other leg. So we get 8 squared minus 5 squared. So you get 64 minus 25, which is what? 34? So we get the square root of 34. And we're going to leave it that way. We're going to leave it that way. Square root of 34. Just the way we got to leave it. Okay. All right. So here's what you would do for sine B. First thing I'm going to do, I'll write the ratio again just to keep track, right? Opposite over hypotenuse. But again, I'll tell you what I want to do is I want to get to angle B and therefore make sure I know what's the opposite side of angle B. Shane, question? Yeah, it's a 34, but right idea. Yeah. 34. And the hypotenuse is the 8. And we're good to go. Square root of 34 over 8. Opposite over the hypotenuse. The hypotenuse is always across from the right angle. It's always the longest side. For time's sake, let's skip the cosine. Let's go to the tangent. So what is the tangent ratio? Say it if you remember it. Opposite over adjacent. Okay, be careful now. Here, I'm going to switch to green. When you're dealing with angle A, the 5 is now the opposite, right? So it's 5 over our adjacent square root of 34. Is that acceptable form to leave an answer in? No, radical police are after you. You got to rationalize the denominator. So you remember what to do? What are you going to do? Say it if you know it. All right, we're going to multiply the bottom by the square root of 34, and whatever we do to the bottom, we're going to do the same thing to the top. 1 second, Mitch. I'll be with you 1 second. So what is the result? 5 times the square root of 34 over 34. That's an exact answer. And that's the way we want to leave it. Mitchell. Is it really? That looks like a 39 to me. 3 times 13, so that still doesn't simplify. Thank you, Mitchell. Shane said that, but I didn't trust Shane. I just thought he read my 4 as a 9, which is possible, right? Because you know how my wonderful writing skills are. Sorry, Shane. I just thought you couldn't read my chicken scratch. All right. I agree. Thank you, Mitchell. No Kool-Aid for you, man. All right. Sometimes when you do mental math, you become mental. Hey, you're going to have to do some of that tonight. Again, make sure you keep track of the angle you're dealing with. Rationalize the denominator where you need to. All right, let's get to our calculators. So you should have a row in your calculator with the sine, the cosine, and tangent. Some of you have to go to a trig menu. There's a trig button somewhere on your calculator, and you have to go to that trig menu. Most of you, the trig buttons are somewhere on the face of your calculator. But again, every calculator is different, and the way you use it is differently. All right, 2 ways we're going to use our calculator. We're going to use it to find angles. We're going to use it to find the ratio. So today we're going to talk about finding the ratio. So again, that's the sine button, cosine button, or tangent button. Not the second function that gives you above it, sine to -1, cosine to -1, tangent to -1. It's the sine, cosine, tangent. How do you use it? You use those buttons and input the angle to find the ratio. And this is really important. You keep track of this. That ratio, that fraction, is going to be in decimal form. That ratio, that fraction is in decimal form. So put a little asterisk here and say, do all ratios to, this is standard, 4 decimal places. Do all ratios to 4 decimal places. Because all the cosine and sine ratios are all less than 1. So a little bit matters, and so we're going to round off to 4 decimal places. We could go to 10, but we're just trying to be practical. And standard is 4. Sometimes you'll see 3. But the more standard procedure is go to 4. We will always go to 4. All right, so when it says sine 35, the degree symbol usually won't be there. They expect you to know that the angle always comes after the trig function, right after it. Whatever's right after it, that's an angle. So how do you input it? Depends on your calculator. Mine, I do the 3, the 5, I hit the sine button, I hit equal or enter, and it gives me the ratio in decimal form. Some of your calculators, you got to hit the sign button first, then the 3 and the 5, and then your enter. So just figure it out whichever way you got to do your calculator. And hopefully you guys are out of radians by now. So when I punch it, I ended up with 0.5736. 0.5736, that's mine. I'm trying to keep track of updates from Vanuatu. So 0.5736. Anybody not get 0.5736? Again, you're probably still in radians. You got to get to the mode, and you got to get into degrees or get into normal mode. So, any questions on that one? Okay, so do the cosine of 15.2 degrees and do the tangent of 623 degrees. You're just punching buttons. Should be real quick. Oh, by the way, who doesn't have their calculator with them today? Okay, very good, Mr. Walker. Why don't you say something here? Come on, borrow this one. Get some practice. No, it's not yours, and you should practice on yours, because when you take a quiz or test, it's probably going to be yours. Or the ACT or SAT, it's going to be yours. Okay, so 15.2 is what? 0.9650? And the 623 is 8.1443. The tangent can be above 1. Sine and cosine. Punch in any angle you want, hit your sine and cosine button. You'll never get a number bigger than 1. Never, ever, 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 never, never, never. Never, 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 ever. Okay. The tangent can go bigger than 1. All right? So what does your sine button do and your cosine button do and your tangent button do? It'll tell you the ratio in decimal form. So what did, look, every 35-degree angle for a right triangle, no matter what size the triangle is, if it's a 35-degree angle, if you divide the opposite key concept by the hypotenuse for every single 35-degree angle of a right triangle, you'll always get 0.5736. Always, 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 because they're similar triangles. Sides are proportional. Every single one. There does not exist a right triangle with a 35-degree angle where the opposite divided by the hypotenuse does not equal 0.5736. Every single one does. That's how trig works. Every single one is always that. 35-degree angle, that's the opposite over the hypotenuse. And it used to be before we had calculators, you had charts. And you had to deal with these big charts and carry around charts, and somebody figured out all the ratios, and everybody had charts they had to carry around. Now we had a calculator, and it's got it all right there. Okay? So that's the key concept. All right, now a subject that students don't like, degrees, minutes, seconds. There's an alternate way of doing degrees instead of decimal form. It can be degrees, minutes, seconds. The minutes is the apostrophe, and the seconds is like the inch symbol, the double apostrophe. So, look, I'm going to tell you this right now. Your book goes degrees, minutes, seconds crazy. And I'm going to tell you right now, and I'll remind you at homework, I don't need you to put them in degrees, minutes, seconds all the time, and I'll tell you the situation, because all it does is make one more confusing thing for students, and it's not good to have students confused. But let's try to get a handle on degrees, minutes, seconds. All right, so let's suppose we've got this example, 54 degrees, 30 minutes. How many minutes in an hour? If you have 30 minutes, that's got to be a half, right? 0.5. All you do is take the 30, divide it by the 60, get 0.5, right? How many minutes? 30 divided by 60, you get 0.5. So what is 54 degrees, 30 minutes in decimal form? 54.5 degrees, right? Because 30 out of 60 minutes is 0.5. That's not so hard. And thankfully, your book usually doesn't go all the way to seconds. They just do degrees and minutes. Okay? So again, 30 out of the 60 is 0.5. So if you're going decimal form, not degree, minute, second form, it'd be 54.5 degrees. Here's one, 83 degrees, 10 minutes. Okay, that's the 83 degrees. And then punch in your calculator 10 divided by 60. And now you're going to convert it to decimal form. And what do you got? 0.1666, so I'll go 0.16 bar. 83.2 degrees if you want to round off to one decimal point. And we normally do round off degrees to one decimal point. Please notice this is an angle. It's not a ratio. We'll take ratios to 4 decimal places. We'll usually take angles to 1 decimal place. Okay? Difference between those. What if you had seconds? Seconds a little bit more interesting. 12 degrees, 30 minutes, and 15 seconds. So there's the minutes, right? The 30 divided by the 60. But how many seconds in a full hour? 3,600, and that's what it takes. You got to add these two up. So here's what we got. 12 plus 30 divided by 60 is easily 0.5, right? Plus, and I usually do this part solely in my calculator. So take your calculator, do 30 divided by 60 to get the 0.5, and hit equals. Everybody got 0.5? Now do plus, and then do 15 divided by 3,600. And hit equals. There's the decimal. So your final answer ends up being 12. Don't forget the amount of degrees. Point, what? 504. And again, if you were rounding off to one decimal place, 15 seconds isn't much, and it doesn't round you up much. Degrees, minutes, seconds. It's an alternate way of thinking. Nautical things go in degrees, minutes, seconds a lot. Aeronautical, a lot of times in degrees, minutes, seconds for angles. It's just one other thing to confuse students. Because there's 3,600 seconds in a full hour, and the hour is the degrees, and the decimal part is in respect to the degrees. There's 60 minutes in an hour, but there's 3,600 seconds in an hour. All right, going the other way is a little bit trickier. Oh, I don't have that page. Okay, so what do we got here? Page 4. Okay, so converting from degrees to degrees, minutes, seconds. Let me put the shade up. Try to keep you from getting confused. Okay, what's simply the reverse process? Take your decimal, right? Let me use my red here if I can get it up. Your 0.5 and multiply it times the 60 minutes. 0.5 times 60 is 30. You're going to get 7 degrees, 30 minutes. If you had 7.2 degrees, you do 0.2 times 60 to get your minutes. If you had 7.8 degrees, you go 0.8 times 60 to get your minutes. If you had 32.35 degrees, 0.35 times 60 to get your minutes. Follow? It's not hard. Again, thankfully the book only goes to minutes, doesn't go to seconds. So I don't even know if I should bother with this last example. But I will. Just in case you got something that requires degrees, minutes, seconds. All right, this is a little trickier. You got to take the full decimal portion and multiply it times the 60. So do that on your calculator. 0.6015 times 60. And hit equals. Do you see how you have 36.09? Okay, so watch. Right now we're at 11 degrees, 36 minutes. And I got to take the remainder of my minutes, the 0.09, and multiply it times my 60 seconds. 0.09 times 60. And I get 5.4 minutes. And that's the number in degrees, minutes, seconds. Again, I hate to throw in that last little twist at the end of an important trig lesson, but that's the process. Use the whole decimal portion, multiply it times your 60 minutes. You're going to have a decimal. It was 36.09. Use the remainder, the 0.09, times the 60 minutes. You might say, why is this 60 instead of 3,600? Because we're doing the decimal off the minutes, not off the hours. Noah. No Kool-Aid for you. Degrees, minutes, seconds. All right, I'm not going to do the last example for time's sake. Do I have any? Did I write the homework? I didn't. All right. Hey, first homework section. You guys got to pay attention. Be careful. It's page 396, 1, 2, 7, 9, 11. Will you use the odds to help you figure things out while you're doing them, please? It's while they're there. That's what the reason they're there for. 12, 14. I'm going to bracket 19, then 18, 20, because I want you to draw the triangle. Draw the triangle. They don't give you a triangle. You draw one. And label it so that you can figure things out. And then finish off with 24, 27, and 30. All right? Foundational lesson in trigonometry. Use tonight to get it figured out. If you need to, go back on HCS math class and watch the video again if you need to, because I did video this, if it comes out.